How's everybody doing? Good. Ogata went for the gold star this week. He got an individual chip to be programmed off of another Arduino board. So that was exciting. Are you doing multiple LEDs off of it now?
Yeah, I'm trying for that. So I got up to 2. 3 doesn't work. Not sure why.
Yeah.
But let me demonstrate. So it's currently plugged in. We got these 3 in series. Maybe you can't tell from the image here. But if I move it up 1, oh, that's 2.
Oh, yeah.
I got those 2 blinking.
Yep. I can tell you why. The forward voltage on a blue LED is larger than the other 2. So if you apply the same power to the 3 of them, the 2 at the lesser, the red and the green have really similar forward voltage drops. So they'll both turn on and the blue one won't.
Okay.
If you wanted to control each one individually, you could take 3 pins on your chip and drive each one separately, and then you can get them to color mix and make like full RGB color spread. But each one would need to be on its own dedicated pin from the chip.
Okay, got it.
Yeah.
All right.
That's a really common thing that gets people, is they like get excited to hook them up in parallel. And pretty much in Arduino projects, you'll want to always put them on their own pin.
Okay, gotcha. All right, well, I got 9 more chips to go.
I just want to make a suggestion, since I think we are all remote while we're doing 100% Zoom, that maybe we just stick to the chat rather than having to go back and forth between the Foundation's chat on Slack.
Yeah.
Does that make sense? And I can even, I know sometimes I've gone back to the chats, so I can even paste the chat. I'm pretty sure it gets recorded with the class, so I can put that into Slack after, so people have that as a reference. But
gotcha.
Unless I feel like it makes sense. Unless if someone has a reason not to, please say so.
That sounds good to me.
Cool. Yeah, let's stick to Zoom. All right, and we can start at any point. If we want, because I think that Lila said she was gonna be moving, so she's in the process of moving right now. So that's a big day. And so let's see, we've got a few people. We're missing Ben. And
missed everybody. I just wanted to say that. I was thinking about gratitude and my Thanksgiving and being a part of this community, and this class has been an absolute delight. I just wanted to slip that in there real quick.
Well, thank you. Yeah. This has been lovely. It's been so nice to meet all of you and have, I feel like, made quick connections here in New Haven, and to have a pleasant time getting to know all of you and build weird things with all of you. All right, so let's we are recording and we're a little bit past 7 o'clock, so let's get ourselves underway. We're going to go through just this week. Basically what we're going to be focused on is a bit of a deeper dive and sort of like the next layer down in code for Arduino, because Arduino coding is its own whole career field, and you can go many, many, many layers deep. And we're not even going to try and get to all of that, but there are some pieces that pop up regularly that are worth knowing. And basically that's sort of why we're doing code first with Arduino. It is a bit of an odd way to pursue Arduino projects. Most of the time, if you look up fun Arduino projects, they have a moving part and they've got lights and they've got all sorts of whiz-bang things that are attached to the Arduino. And I think that those are really great and really good immediate next steps that a lot of you are probably going to try and pursue over the next 2 weeks. But for us, and for like the sake of studying it, I think it really helps to understand the code a little bit better, so that when you find those examples and the instructions online, you can make sense of it as you read through the code that they give you. So that's essentially why we're doing code first with Arduino. And these concepts are the more advanced ones that don't always pop up in examples, and they won't be the first thing that you go to learn, but if you might run up against them. And so when that is the case, it's worthwhile to take some time and know these things, just because they pop up and they can be really confusing if you've never heard of them. So they're really good to have heard of and sort of work through. Also, there's those lessons that I made and put out there in the world. Those do exist. And can you let me share my screen, Kate? Those lessons that I put out there in the world, they do cover these concepts. So you get to play around with them a little bit too, in case you're curious and you want to learn a bit more. Those are all available for you to look at. So these are like next level down the rabbit hole of Arduino code projects. So we're gonna try and get to there. Let's see. Oh, cool. All right, share my screen. So we're gonna take a deeper look at all these things, but these are, again, here's the scopes lesson. So these are sort of the things that we're kind of loosely tying our study on. And I'd say if you're brand new to Arduino and you've made it through 5 or 6, maybe 7, 5, 6, and 7, then I'd say if you're brand new to Arduino and you make it all the way to 7 and you feel like you've got that rock solid, that's a really good place to be. And it might be worth it to start to think this week about how do you want to pivot? Do you want to jump into LEDs or motors or any of that? But with that, we're going to talk today strictly about the code pieces. So we're going to hop back over here and do some presenting. So this is embedded programming part 2. So you think you can code. There's all the basics that we went through in the last week, which was lots of stuff. It was sort of the basics of what it takes to write a program. Then there was the if logic for Booleans, and then while loops and for loops and arrays and all those like core pieces that are really at the heart of writing code. And we're going to get to things that are a little bit more subtle this week, because they often will pop up and you'll need to know them when you're looking at an example, but they won't jump out at you in the same way. They don't become immediately Googleable, is often the case with these. They're not the thing where you're like, what's that while loop about? And how do I Google what that is? These are often harder to find without a little bit of an introduction. And so we're going to take a look at some of these. And this little guy just hit me right in the feels. You open a month's old an old file of code, and if it's readable, logical, and it doesn't need changes, you're all good. Whenever I open an old Arduino project, I really often find that like I was so bad at writing code in the past, and I'm still bad now. But every time you look back in the past, you get to reflect and enjoy that you've gotten better. And so that will be the case for you if you go back and take a look at the things from last week, this week. And it will also be the case if you look back at the things from this month, 3 months from now, right? You're going to keep getting better. The more you try and do this, the more you play around. And so you're going to get better and better. And so it's always exciting when you can look back at things and they're good. But most of the time you look back and you can really see your growth, which, that's maybe the opposite of what this little kid's showing. But anyways, the things that we went through were sort of the basics of math, variables, arrays, Booleans, while loops, and for loops. And those are the words in the sentences, I would say, to the code for Arduino. Now we're going to start to step back and think more about the paragraph size structure. So how do you do the big ideas? What are we talking about when we go through those large concepts? And how do you plan out a program in a useful sort of way? And so getting you past the basics really gets you to a point where you can start to do these deeper level things, where you can start to think about the structure of what you want to write. But the same rules still apply. There'll still be moments where you feel like you're super great, and there'll be moments where you have no clue what you're doing. And that's still essentially the two states of every programmer. But we're going to work our way through functions in code, variable scope, which is one that I think is especially tricky because there's no good way that jumps at you. Readability and maintainability, which are partners in crime. Then we're going to talk about object-oriented programming, which is if everything we've done so far is learning how to add and subtract in math class in elementary school, object-oriented programming is essentially learning how to multiply and divide. So it steps it up a notch. You get more complicated, more interesting things that come from object-oriented programming, object-oriented code. And then we're going to see how that's used. You've already been using it, actually, which is really exciting. That it's not some foreign, far away thing, that it is still something that you've been using when you serial print. You've been using Arduino libraries this whole time. And so we'll get that under wraps. So the first thing that you should know is that functions are everything in Arduino. And it's, well, maybe not strictly true, that basically everything that's important or meaningful or that happens in an Arduino happens because it's in a function. And so you may not know that immediately. And the biggest question that brings this up is, what is that void thing? Why is it void setup and void loop? It takes a second to realize that void setup and void loop are actually functions. They're both void class functions, and functions can have class just like variables can have class. And so you have those different classes. They're void for setup and for loop because they don't return anything. They don't give you back any sort of a response when you do a void setup or a void loop. They're not giving you any pieces, as opposed to like this little example down here where I wrote a different function. So here there's void setup and void loop, but I think that those are hard to wrap your head around as functions until you see a different weird function. And so here's a little one that says, that's named add. This function is named add, and its variable type is, its function type is an int. And so it's got two parameters, two things that I pass into the function, item A and item B. And then what it returns back to me, this little tiny function, is just A plus B. And so I put in two numbers and it spits back the sum of those numbers, which is why it's named add. And so up here in these two sketches, this is the example that you looked at last week or the last couple of weeks, where you had some variable, you did addition here, and then it spit back to you that answer. Here it's doing pretty much the same thing, but it calls the function add, passing in the values A and B. And so when I do this line right here, and let's get the pointer, it might be a little bit nicer to look at. So when you do this bit right here, what you're doing is you're telling your code, okay, don't just go down through line by line. I want you to take a moment right here and go find this function, this add function, and you can pass information in. You can pass in variables. These are called parameters. And so those parameters then can be used by the function. And then functions can return values, but you have to tell it what the class of the function is so that you can return back something that's useful. Like in the case of C, it needs to be filled in with a value that's an int because that's the class of the variable. So you need to return an int back to it. Then I can print out C just like it's the same thing. And this is, it's weird, right? That I'm doing basically the same thing, and it's a very trivial, it's a super easy thing that it's doing. It's just adding two numbers. And there's not really a whole lot of memory benefit to this. Like if you look, they both take up 5% of the space, the same amount of memory in both cases. And so this is sort of a weird thing to do. There's not really a memory cost benefit, but what it does do when you write functions like this is that they can separate out logic in ways that makes it more readable, which we'll talk about later, or makes it more isolated, more maintainable, which we'll talk about later. But it makes it maybe easier to think about if you start to think about your programs in terms of functions. So you can have one function that does this, one function that does that, and it can be really helpful if you want to do something multiple times. And so when you're doing something like that, it can be really useful. Arduino itself, like Arduino, the entity, they recommend declaring functions in your code. And so for a long time, actually, when I was first learning Arduino, I wouldn't ever write my own functions. I wasn't sure what void was, and I wasn't sure what int meant at the front of a function, but I'd seen it a couple times. And so I didn't know what to do with something like this. But I knew fundamentally that I wanted to make my own, like, oh, if you're running through the code, I wish you could stop and go over here and do this other thing, and then come back to what you were doing. Like in my mind, I had that logical flow, but I didn't know how to make it happen. And so defining your own functions is the way to go, which is exactly what we're doing here. And Arduino completely endorses this. It's the way to do all sorts of good coding work. And so standardizing your code fragments, the like little chunks of code into functions, can really be beneficial. It can help you stay organized. One thing that is really helpful is it can make one action live in one place in your code. So if you want to do something 15 times, you don't have to write the same code out 15 different places in your program. You can write it once and say, go run this function each time you need to do it. So it can reduce the amount of code that you need. It reduces the chances then for errors. Because if you have to type the same line 15 times, that's 15 options for a typo, which I am very prone to make. But if you have a single function that you get it right one time, then you just refer back to it, then that's a lot less opportunity for those typos and those errors. It often, when you get a big program, not the one that we saw, that I just had as an example, but when you get to a big program, it can really compact your programs also, so that you don't have long repeating patterns in them, so that you just have the smallest functions that you need to have. And so as you get larger and larger programs, adding more and more functions actually shrinks it, which is kind of paradoxical. And then it also makes it really easy to reuse code, is why functions are really helpful. And I've got, if I hop out of here, I go over to this, I've got just another example. And so here I've got 2 arrays, and we looked at arrays a little bit last week. This is just a Fibonacci sequence, 1 and 1 and 2 and 3 and 5 and 8 and 13. One is in the array named foo, one is in the array named bar, and you'll often find these as the names for variables in code message boards. But in here, I'm just using this example to start a simulation, and I want to add up the values in each one of these array lists. So I'm adding 1, 2, 3, 4, 5, 6, 7 pairs of numbers. So I'm repeating that many times. And you can imagine that that would happen lots of different ways. But in this case, I'm using a for loop to just jump through and do this 7 times, where I tell it to add the variable from the array here and the variable from the array there at these positions, and go through basically all of the array and do that and print out the number. So you get that, and then here it goes. I put it in the setup so that it only happens once. The loop isn't really anything, but it has to be there. And then here's the adding function that's basically identical to the one that we just saw. So this can take a relatively complicated task that's adding multiple things repeatedly over time, and you simplify it by just having the one function that gets called multiple times with, in this case, a for loop. Or maybe it needs to happen when a certain condition is met. And so you can do custom functions like this that can make your life easier, because you can just say, well, I'd like to add those, and then do it. Okay. So functions are really an important part of how you can work with programs, and learning how they work and how to read them can be really helpful.
Corey,
Another one that's, oh yeah.
I just want to clarify something in my mind. So when you wrote that function add, and you use the variables in A and B, I just want to make sure A and B, are those little mini well,
yeah,
they don't have any, they're just like normal math variables, right? That
Yep,
you'd
they're-
use in like algebra or whatever. They have no value. But
right.
you can apply them up there. So, because I think of int A as an int that's been named, like an integer that's been named, and now I can call that integer something. But what you're doing here is it's A, and it's basically a blank that can then be applied to foo and bar.
Right. And so basically what happens is I'm passing in, when I do this in the function and I declare this, I'm like kind of doing the same thing as when I create the variable C up here, but it doesn't get defined when I write it in line 16. The variable A gets defined when I pass in foo. And it might be easier if I stop the simulation and I just say 8 and I don't know, 3. So here I'm passing 8 in for the value of A, and I'm passing 3 in for the value of B. So I'm naming the variable A and B in line 16, but I assign its value when I call the function. That's why they're parameters that get passed into the function.
Right.
And so foo and bar were just using a clever use of for loops to pull them out of these arrays. But like basically when you call the function, that's the moment that the variable whose name is down here gets defined, is when you call the function. Okay. And so then this would be adding 8 plus 3. So if I run this and start the simulation, I should just get 11 a bunch of times, 7 times. So that's exactly how those work. And it's a little different because you're not directly saying the value of A or the value of B when you define the function. You're doing that when you call the function, which is what happened up here in line 8. So yeah, that's a really good question.
Okay.
So another question, can we put like an unlimited amount of functions within the void loop?
Yeah, you can call however many functions you want inside the void loop. So you can define all the functions you want. Generally, you want to define a function outside of another function. And different languages have different rules about that. And I'm now forgetting about C. But I think you want to define your functions outside of void loop, but you can call them inside of void loop whenever you want.
Okay.
Yeah.
But you did add your function inside of void.
Void loop begins and ends on 13 and 14.
Oh yeah, I see the bracket. Okay, sorry.
Yeah.
Also,
Yeah.
This
Yep.
doesn't look. Can I?
All right.
See it?
And
Because
so let's see. Next up, we are in here
It's
for
all right.
variable scope.
Can you get? Thank you.
All right. So variable scope is one of the more subtle things that can be really perplexing when you get started. So I've got a graphical thing that to try and make it work. This is actually implied with every variable you've ever used or pulled up. And so it really is helpful for you to know how this works. You can get by a long way without knowing what this is. And I had a friend who's a developer who first introduced me to this idea, and I had been coding Arduino for a long time. You can make it years without really understanding this, but the sooner and the faster that you get scope and how it works for you, the better off you'll be, because you can reuse names in programs that you might want to use more than one time. So here I've got an example on the right, but the thing that you need to know is that variables have a space that they can be used within. So when you declare or name a variable, it can be used in any area that's that size or smaller in your program, which is a little hard to read. But basically here I define 3 variables. The one on the top is named Pat, the one in the middle is named Sunny, and the one in the bottom is named Nico. And then inside the void loop, I just call Pat, Sunny, and Nico to be printed. So it'll print out 6, 8, and 11 if everything were to work. But one of these 3 is going to cause an error. And so it's worth it to just take a second and like pick one. See if you think you can tell which one is going to throw the error. Would it be Pat, Sunny, or Nico? Which one of those is the one that's going to be the problem? And I'm not going to sit here for super long, and I'm not really going to make you answer, but it's just like a good it's a good question to entertain, because you make a bet, right? And then you see if you got it right or not. So here we go. Here's the answer. Sunny will be the one that throws the error, and it has to do with this color coding. So Pat up here, you've seen global variables before, and you've heard me reference them, and they get talked about in the code in those coding example lessons. But Pat is a global variable. It's defined actually outside of a function, and this is where maybe not everything in Arduino is a function. That you can define a variable like Pat outside of either setup or loop. Sunny is defined inside of setup. And so Sunny can only be referenced by things inside of setup. He can only be read or written to inside that green box between the curly brackets of setup. So Sunny is scoped to just void setup, whereas Pat can be referenced in setup or loop or in another function that's further down. And Nico is scoped to just loop. So Nico couldn't be referenced if I tried to pull him up in setup. If I tried to serial print Nico up here, I wouldn't be able to do it. But down here, I can serial print Nico because it's inside this function. And I can serial print Pat because Pat's referenceable as being inside that area. But Sunny is sort of in the container that is setup. So when you define a variable, it can be referenced anywhere that it lives at the same level or in any child of that level. But it can't go up any layers, which is really helpful. It means that if I want to have a series of functions that are kind of repetitive, and I'd like to have repetitive names, but they're isolated in terms of scope, I can reuse namespaces in sort of sibling functions, which can be useful. And so it raises some interesting questions. Like, why wouldn't you make everybody global like Pat so you can just use them anywhere and you don't have to worry about it? And that's actually a really good question. And lots of beginners just do that. They just make every variable they've got a global. I did it for probably about a year, and it can work really well. The problem is that if it can be accessed and read anywhere, it can also be written from anywhere. So you can have something in your code that behaves just a little bit different than you expect, and it can change the value of your variable without you really being attentive to it. And so it's generally bad practice to make global variables out of everything. ideally you want to have your variables as low in scope as possible. So avoiding globals if you can. Can you reuse names? Absolutely. I really love it when I can reuse a name for like the value reading off of a potentiometer, because then I can make something reasonable, like what's like just value for a variable name. And it might make sense to me in my code. It might be perfectly reasonable as a name for a variable. And as long as it doesn't conflict with something else in its scope, then I can reuse names again. Like I couldn't use Nico a second time in loop for a different variable. That would be just reassigning it. It wouldn't be a separate variable that I could store. But I could, in loop down here, I could reassign or redefine Sunny if I wanted to. If Sunny was really helpful to have up in setup and then also a helpful variable name in the loop, I could redefine Sunny. And since they're sibling scopes, I wouldn't have a conflict. So it can actually be really helpful to do that. But actively managing it is what we're going for here. And then there's another deeper level for this, which is pointers. And I link to those where you use and signs and then asterisks. This is another thing that you can do with variables, but I'm going to go with that's advanced and something that's interesting to entertain, but maybe not a for today activity. But pointers are really fascinating, and they really get closer to, I would say, the hardware of how memory works, that there's memory address locations, and you're like pointing variables through to different spots. There's some clever tricks for it, but maybe not a right away skill.
Corey, can you give an example of where a global could jam us up?
Absolutely. So let's say you get into the cycle of trying to make readable repetitive code so that you just like, you have a pattern and you stick with it. If you wanted to say something like the value, right, of something, you just use the name value and then you wanted to use it again somewhere else, and your program's really long and you forget that you had defined it, you can define it. And when you redefine a variable, Arduino won't actually throw a compile error. So it will compile just fine because it's completely happy to redefine it in the new scope. And it will let you do that, and you can compile and assign a value and it won't be a problem for the compiler. But it's a problem for you because it won't work the way that you want. And because you don't get an error that's thrown from it, it can be really problematic. So this can give you either thrown errors and you're not really sure why. Sometimes the error message will be clear and say it's got a scope issue. Like the variable is not defined in this scope is a really common one. But another thing, yeah.
And won't it favor the local variable so that everything that was global will start to act wonky because the compiler is favoring the you know what you define, what the integer or the variable, I mean, within that that local area, which would maybe be the loop.
Yep. And I think that you're totally right that it has a preference for the most local variable. So if you have conflicting ones, you can get different than what you expect. Or you can get that out of scope area error. And if you don't know what scope is, it can be problematic. And it's definitely one that I think is a weird, it can catch you off guard if you don't know that scope is a thing for a while. And so it's really helpful to have. But the biggest thing that I've had with scope errors in my life when I'm trying to like work through a program is that it'll often not tell me that something's broken, but it's broken. Right. And that's the worst kind of problem when it like half works and you're kind of there, but you have no idea why it's half working. Those are, in my opinion, those are the hardest problems to solve when you've got no foothold to get started with. So it's definitely something that you want to take into account. And there's some languages that really have a strong preference for the most global or the most local. And I can't remember for C. I think you're right that it's the most local that it prefers. Maybe they always prefer the most local. But that's definitely a thing that you want to think about and actively manage. I think the main lesson that I want to get across here is that variable scope is something that you want to actively be thinking about as you're writing your program. And so when you define a variable, do you want to define it inside of a function or do you want to define it outside of a function? and how is that going to fit, right? Like if you are doing something at the beginning and you're like reading a potentiometer, you're getting it ready to go, you do that all in the void setup, but then later you're going to want to use it in the loop. You have to define something that will persist once the setup function ends. So you've got to be strategic in where you put your function, your variables, so that they can exist beyond the end of a function, or that they specifically don't exist beyond the end of a function. So it's just more managing that and like keeping that in mind as you design what you want your variables scopes to be. So yeah, that I think is the big one there. But it brings us pretty nicely to the idea of readability, which is something that's really important to have in code, but it's actually completely optional. You can write very impossible to read code that works super well and is actually really efficient for memory, like memory use in your Arduino. But it's something that we absolutely want to take into account if you're ever going to revisit code. And so here I've got 3 examples of what is less and more readable code. They're all just basically the Arduino example of Blink. And on the right, it's the least readable, I think. And on the left, it's the most readable. This isn't a vast swing in readability, but it is on the right-hand side. It's blinking the LED that's built in on pin 13. And I added a comment, which is I've loaded code that has no comments in it, usually written by teenagers. And so they write code with no comments at all. And then you've got a number for the pin that isn't a variable. So you have to like reason out, why are they using 13? Is it a digital pin or is it some number that they used? And then high and low can also be sort of mysterious when you're getting started with Arduino. So this, I think, doesn't tell you very easily what it's doing. It's digital writing to 13, high and low. This one is a little bit more readable. It tells you that 13 is the LED and it stores it in a variable up here. Maybe this should be a constant variable, but it's a variable nonetheless. And just by switching it out from a number to a name, it becomes more readable, that the LED is being written high or it's being written low. And it maybe uses a little space. If this were a const int, it wouldn't use any memory. And so the const constant integer, you don't use up your memory space, or you can use a hashtag define, although probably const is better, is what I did a little research with Jamie earlier on. And so const int would not eat up any memory, but you'd get a little bit of readability by just making that one change. And then I thought that this was maybe the most readable way to do it, without making huge changes to the code. You still have your LED defined, and then glowing is just written as high, because if it's got a high voltage applied, if 5 volts are applied to the LED, it would be on. And if it's not got 5 volts applied, then it would be off. So down here in the green box, it's an LED that's glowing, or it's an LED that's not glowing, right? And because it's a Boolean, if I put not in front of it, it goes from high to low. So this might be the most readable way, provided you really know rock solid that an exclamation point means not. So these are various ways to write the same exact thing. It's the same output, it's the same function. There's no major changes to this at all. But I think that on the left is more readable and on the right is a little bit more abstract. And so thinking about how you want to write your code just so that you can go back to it and make sense of it later is really helpful, or especially if you're working with people, because you might be able to keep in mind, like, okay, this is what that means, this is what that means, and you can keep it all good if you're working on a project right now or for this weekend. But usually if you're collaborating with somebody, having it be readable is really helpful. Or if you're working on it and then like 2 weeks later you come back and revisit, or 3 months later, like that little kid, you want to make sure that your code's readable just for yourself. And so there is some guidance that Arduino offers. Oh yeah.
I'm just wondering how bad a strategy this is as someone who's completely new. I know this is going to make code longer, but I was thinking I would probably just have a lot of comments and basically be putting like, this is what this means, basically translation as I'm learning it.
Yeah, and that's actually the best way to improve your readability. Is comments easily are the most effective way to add readability. A pro developer, where like everyone assumes that you understand all of the code parts and you're like only trying to figure out the quirks to your application, they'll comment differently than all of us in Arduino land will, but just adding piles and piles of comments are totally the way to go.
If I may, I have a question about the syntax,
Sure.
and then I also wanted to say something about comments. So
Yeah.
I just for background, the code that I do is not object oriented, so this is still very, very new to me. I've seen a lot of it and I can sort of understand parts of it, but placement is always something that I'm very curious about. So I'm going to go ahead and ask, like, why place a bracket in a given space? Like, why are they maybe not aligned to sort of like follow the nested sort of nature of the brackets? That's my first question.
Right. And that's totally a style thing. There will be
Okay.
people who'll have super strong opinions about, should I take this little add function down here and should I write it like this where it's there? And then other people will say, absolutely not. It should always be written like this.
Okay.
Where that curly bracket is above and this one's below.
Okay.
And so this is probably the more universally liked one. I have no idea why this became the one that my brain connects with better.
That's fine.
But it's totally a thing. That in a company, I would imagine they'd have a style guide that says like this, only one of these is going to happen.
I wish I saw more of those. But awesome, thank you. And then the second thing I wanted to say about comments, there is something so satisfying about like going into someone's code or even your own code and being like, if it was worth putting the time and effort into this to begin with, putting in comments is always huge. If I tried maybe like 3 or 4 different things and none of them worked, I could even put that in a comment, just so that way, like, I wouldn't be, spinning my wheels and doing the same thing over and over again.
Yep.
It can obviously get messy, but what's awesome is you can be like, all right, I know this piece works, and I'm going to try to add on another little piece. And, once that works, you can sort of integrate it into what you're doing. So I find comments are valuable, not just for making sure I'm not going crazy, but also in like feeling like I'm getting a sense of direction and progress, even if I'm beating my head against the wall. So
absolutely. And that's a really good point. Like, let's say that hypothetically, this isn't an add function, but like, I don't know, exponent. And I don't exactly, anyways, maybe my spelling's wrong, but when you're doing this, like, I may not have immediately gotten it right and be like, well, that was wrong. So I'll comment that out. And so that I just have that line like present, but I can like check it off as, okay, here's one thing I tried. Right. And then come down and, well, that didn't work. Let's try return a caret B, and maybe this will work, right? So I can like try those, and by just commenting out the code that didn't quite work, or I temporarily don't want, that can be a really helpful way to use comments also. So like, as you're trying code, you're writing comments for yourself, like in the moment, so that you've got that. Is that one of the things that you were saying that you do?
yes.
Yeah,
Absolutely. Like, it's often that I'll be working with code and I'll be like, all right, I understand what I think I need to do, but there'll be some sort of nuance or aspect of the data that I work with that I need to know like exactly what's happening. So sometimes I get to speed through parts of it, but eventually I'll come to a place where I'm like, you know what, I really need to fine tune this. And using comments is great, because then when I go to explain it to other people, I can say like, this is sort of my thought process and how I got there. That way it's not just the product, but it's also like, how was I thinking to get there? And that makes it easier for other people to provide like feedback or perspective. It's helped me learn a lot faster. So
yeah. And that's totally, it's one of the great uses for comments. Comments should be absolutely your friend, and writing as many of them as you want you should never feel bad about. I would say it's only the crankiest programmers who really try to avoid them, where they think it slows them down. They think that they got too excited about being a deity in the coding. Writing a lot of comments is the way to know that you're working hard. Yeah, so comments are a totally good way to be readable. Another thing that's really helpful is to think about the white space and how you space it. Like, do you want to do this convention where your curly brackets come on in the line of the logic, or do you want to have them down a row? And then also thinking about like, well, I've got this and then like a vertical stripe down to where that ends. And so these are nested like this, that lets me know that this curly bracket goes to that one and this curly bracket goes to that one. So like using the shape of your code can be really helpful. It's easy to type in characters that just sort of make it happen. And I've got in the lessons, I've got an example that's like, it's just terrible to read because all of the spacing is wrong. But white space is super important in making your code, understandable. So it's totally a thing that you want to think about as you're going. And sometimes you might think like, boy, I wish this variable had a really like descriptive long name. There's totally a solution for that. And it's camel case, where your first word has got a lowercase letter and then every subsequent word has a capital letter to get it started. So that's completely a valid way to make sure that you have long enough understandable names. I would still avoid like sentence, but if you need 3 words, go for it. Using camel case. The next piece is maintainability. And so this is a quote that's super famous in developer world. Always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. Right? It's just a little subtle nudge to make sure that you write enough notes and that you're clean enough with your code that you won't mind maintaining it later on. It's a lovely one. But maintainable code is similar and related to readable code. It's code that's clear, that has the information that you need if you were to go make adjustments to it. And maintainable code is also really nice when you can isolate out logic pieces so that you don't have like one really complicated function that does 15 things, but instead you've got 15 little functions that each do one thing. That's a more maintainable program because you can isolate this is broken and that's not, versus it's all sort of jumbled together, right? Like think about trying to find something on a messy desk versus a well-organized desk with file folders, which is a dream that I have for one day for myself, but don't often make happen. So just to be clear, being maintainable means always writing comments. You can write and call separate functions for repeated processes. Isolating logical steps is really helpful, and build properties and objects that mimic real world. And that's not often true in most programming scenarios, but the object-oriented stuff that we do for Arduino, you're going to find that if you can make a code object that imitates a real object, that's going to be very helpful. So if you have a code object that represents what a button does, then that'll help you implement a bunch of buttons. And so we're going to look at that right now. But maintainability and style guides are super, like they're hotly contested. There's lots of books for how do you write the most maintainable code, or what's the best style to use. My old roommate was a developer, and I remember him going back and forth about all of these different ideas with his coworkers through phone calls. So it's interesting that this is still something that's very opinionated about how you should do it best. But object-oriented code, this is probably the biggest item that if you really crack this nut, you're in a good spot for understanding how to do some of the more complicated things with Arduino. And object-oriented code is why Arduino is really based on C++ instead of C. C is an older language. It's still used for lots of things. C++ includes objects. And so it's newer. And by newer, I mean like from the 80s, I think. And so it is newer than C, and it gives you an ability to treat code as a series of things with properties and with behaviors that it can do. And I think Adafruit really teaches this much nicer than I can. So I will totally defer you to the Adafruit lesson, but I'm going to try 1 or 2 visual things just to show you what I mean, because code objects don't necessarily sound intuitive when you're first getting to them. But just for a use case example, like here's an Arduino project, right? I've got an Arduino on the left, and here's 6 LEDs and 4 potentiometers. Maybe I'm making some light-based instrument thing. I don't know. But if you've got these, this now all of a sudden has become a lot of things to manage, right? And so all of my LEDs, they fundamentally operate the same, and all of my potentiometers, they all fundamentally would operate the same. But if I could just write a description for what one of these can do and what one of these can do, then I just say, I want to multiply that by 6 or by 4, or by however many you need. And so if you write object-oriented code, you can define what an LED is and what it should do. and you can define what a potentiometer is and what it should do. And then just say, well, I'd like to invoke another one of those. I'd like to bring another one into our code. And so it's a tricky way to start to think about things, but it really becomes helpful when you get better at it. You start to think in ways that are really useful for getting better and more integrated into object-oriented code. And it's common across most languages that are modern enough that you'd be dealing with them now. Python uses it. Python even uses functional stuff, which is different. But there's JavaScript is object-oriented. There's lots of different things that have objects that you can play around with. And so let's break down what an object is. An object is a class. And so they have slightly different ways that they get called, but class is the most common way that you define a function. So in this example, I'm going to have classes for just the LEDs from that past picture. So a class could be called a flasher because these are just, or it could be called LED or whatever you want. This is the namespace for the object. And the object might have some variables that are defined for it. So the first variable here is the LED pin. That's something that I would need to know for my LED to work. And I might need to know other things, but in this case, I'm just going to stick to one variable. And so this is a private variable. Anything below this little public declaration becomes a public item. And so the constructor has to be your first public thing. So I've got a flasher, and typically a constructor has a capital letter to start it, and it's a function itself. So it's a flasher, and I pass in a variable to define the pin of the LED. So I've got a variable LED pin. This is the parameter for the constructor. And that parameter gets passed in, and it defines, it assigns a value to the LED pin. And so then in the constructor, I do anything that I need to do with setup. And so to set up an LED, you say pin mode output, which is just setting up the LED to be ready to go. Then here are the methods that this particular code object has, and those are things that the object can do. So this is sort of defining the properties that the object has, and it's only got one property in this example. And these are the things that it can do. And this is how you make it. The constructor is how you make it. So the two different methods are turn on and turn off. Kind of laughably simple, but they do a few things for us, right? Like this has digital write LED pin high and digital write LED pin low. So it goes to that pin and it writes it high and it writes it low. And that's all it does. But then we can use these objects in our code. So down here, I instantiate, which is a fun word. I instantiate flasher objects. And this is a flasher object whose name is LED1. And I pass in the parameter 12 because it would be on pin 12 on my Arduino. And so that's what this 12 means, is that it's on pin 12. And so that it gets passed in, it's the LED pin, and that's set as an output when I instantiate it. Then I instantiate another one called LED2, and that's on pin 13, so the next pin over. Then in the setup, I don't have to do anything because when they're instantiated, the pin mode function runs, and so they get set up as outputs when they're instantiated, even outside of setup. And then in the loop, the thing that's really great about object-oriented code is that your methods can be really readably named. So LED1, turn on. LED2, turn on. Delay 1,000 milliseconds. LED1, turn off. LED2, turn off. The method names being so readable makes this a very understandable sketch that the loop is going to go forever and ever. And you turn on LED1, you turn on LED2, you wait a second, you turn them off, and then you wait another second. So objects not only can isolate the logic into one area, but they can make your code incredibly readable when you're running it. So it can be super helpful in lots of different ways. And this is definitely like next level of code use. And so you don't have to do this. You can do lots of things without object-oriented, but it's a super useful piece of code for you to use. And it's definitely a fun one. The better you get at this, and the more you think about your code as your Arduino project components as code objects, the better off you're going to be. And actually, this may sound like a foreign idea or a more advanced idea, but you've been using it all along in libraries. And so in libraries, which the library did not need any more advertisement to get nerdier, but here we're talking about libraries in code. So, it's fun. Libraries are really helpful when you've got complicated hardware that you're trying to put in. So Arduino shields are a great example. You can buy these on SparkFun or Adafruit or in like other off-brand things that are, who knows where they come from. You can buy all sorts of weird hardware. But a lot of the time, if you have a good vendor, and there's plenty of reason to find a good vendor, they'll also spit out a library that goes along with the shield. And the library basically pre-packages an object for you in code that somebody else wrote. So you can access an object that somebody else made for you that's perfectly matched to your hardware, and it's sweet relief. That's the magic that an Arduino can bring, is that you can learn how to use real complicated hardware without really needing to know the details of how it works. It's great if you want to go that deeper level, and you totally should nerd out on it if you've got the time. But you can also quickly slap things together if you've got a shield and a library that work well together. So they're just pre-object-oriented code, and there's tons of them actually already installed. Yeah, what's up?
Can you go back to that picture before and just make sure, am I seeing it right? Like when you say shield, do you mean basically the thing that sits on top and plugs into the Arduino? That's the shield? Or
Yep, that's exactly what I mean. So like this guy, the red SparkFun, is sitting on top of an Arduino and it's just plugged in. And then here's one that wouldn't have anything else sit on top. This one can have things sit on top. This one can't. And here's like a stack. You can sometimes, and it's not all the time, but sometimes you can stack them like this. And they're a shield because they literally cover it like a shield. And so we're going to get more into that when we get to
So
the,
that
like,
red SparkFun on the top left must have male pins like the one below it in order to fit into.
Yeah, you're totally right. And this one, it looks like this is a motor driver. So these are all diodes, and this is a motor driver chip. This is going to be tied into a few of the pins on the Arduino below. And the library that you get from SparkFun will do all of the code work so that you just say like drive motor forward. And you don't have to worry about what pin is connected to where or any of that. And a library from SparkFun or Adafruit are going to do that super nicely so that you can just say, you can focus on what's the high level stuff. So motor drive forward. You don't have to worry about connecting to this pin or connecting to that pin. They'll have taken care of all of that for you from SparkFun or Adafruit.
Is there a difference between a shield and a hat?
Almost no. A shield is for Arduino and a hat is for Raspberry Pi, but they serve the exact same function in those separate ecosystems.
Thank you.
Yeah, no problem. And it's just a branding thing. I mean, if they had all agreed, they would come up with one name. They could have, but the pinout's different, so they need a different name. Arduino has stackability. I've not seen many Raspberry Pi hats that are stackable, but Arduino can do this. So that's kind of a fun trick. And this looks like it's 2 motor shields and then something else on top. These are often really the best way to do them. This one and this one are both motor shields. This one looks like it's for some sort of, I don't know what this is actually. I just found an image and it looked good. It doesn't even look like it's maybe an Arduino underneath. But this idea of a shield can be really intimidating because this can add a lot of complexity without a library. But when you have a library, it can be super easy to make happen. And so they're lots of fun. You have a ton of libraries that are already installed and you use them all the time. Like Serial is a library that has been installed the whole time. But there's a bunch of others, like Servo is installed and it lets you run hobby servos without needing to know that they're really run by a PWM signal that like has modulation amounts and you need to have it exactly tuned. So you go to different locations. All of that is abstracted away, so you don't have to worry about it. There's even a library manager that has been added since I started playing with Arduino, and I've got a picture of it over here. If you go to Sketch Library Manager, this is great. You can search for libraries, and these are all the canonical ones that are like Arduino approved and they will work. And you can get them updated. If they get updated, it gets notified here, and like you'll get a notice that you can update your libraries. So the library manager is awesome. You can also install libraries from zip files, and you can do that through Arduino where you say install zip library. You used to have to unzip them yourself, put them into a folder, and then like cross your fingers and restart Arduino and hope that it worked. They've since solved that problem. That was like a 4 years ago solved problem. And so now you can just install from the zip file itself. Arduino will unzip it and put it in the right spot for you. And those go into your, when you make when you install Arduino, you get an Arduino folder in your programs and you get it in your documents. If you install any libraries yourself, they go into your Arduino folder inside of documents on a Windows computer. Adafruit contributes tons and tons and tons of libraries because they want people to buy their hardware and they want them to have no obstacles in getting it started. So there's tons of Adafruit libraries that you can use, even with, and they make it all completely available. So you can use it with knockoff circuits. There are plenty of companies that will make a very cheap shield and then just say like, oh, we use the Adafruit library. So that all they have to do is put it together, package it, and then sell it to you for more than it's worth to make some profit, which is, it's good business, but they're using the Adafruit libraries to make that happen. And then documentation for libraries, I will say, can be, sometimes it's a bit spotty. Adafruit is the shining star in this example, but sometimes for a weird one, you may have to dig into the files itself that are telling you how they work. And so that's a little bit tricky. But a good documentation will really be there for you. So serial is the prime example. You've been using this the whole time. Begin is a method that runs on the serial object. Because serial is so integrated into Arduino, you don't need to instantiate it and you don't need to do lots of things on Arduino Uno. It's made to be beginner friendly. So serial just works. If you put it in there, it's gonna happen and they know what you're doing. So you say serial and begin. This is a method that you're running and the parameter is 9600. Print will print out something. Print line is a different method and it's only different. It calls the method print internally actually, but it tacks on an end line character so that it's like hitting return after you type the D in world. It does that for you automatically with a print line. You can actually manually type in the end line character in print and it works exactly the same. And so these are all, you've been doing this. So don't be intimidated by libraries. This is totally something that you've been up to the whole time. And you can completely make this happen for yourself. You can play around with these and they're super, super helpful so that you can get to very complex things in a very short amount of time. So I totally recommend that you play around with libraries. If you have access to a servo, they're a great place to get started. That's a really common library to use. And it's tons of fun. This is actually the end of our new little notes. The one thing that I would have, if you wanted to try and do some next steps, I would say try and toss in LEDs, and Wagata is going after it. I bought a bunch of LEDs that I'm going to put on the foundation's shelf, and resistors. They're scheduled to come in by Friday because holiday shipping. But then just grab some. There's like 400 LEDs, so please take a few. I think that would be 40 each if we wanted to meticulously dole them out. But just grab a handful and then play around with hooking them up. And then you can use them to play around with code. And if you have 8 LEDs attached, now you've got a good opportunity to try and use some object-oriented code to try and make an LED object. Maybe you make an object that instead of blinking or turning off and on, it fades. And that fade is a method. Or that the blinking itself is a method and you pass in a parameter for how quickly you want it to blink on and off. There's tons of options for how to get better at working on code with just LEDs. And so we're going to have these around for you. There's probably also a pile of them sitting in MakeHaven somewhere, but I just wanted to replace the divots. So those are on their way. Also, we're going to totally look into LEDs on their own. They have an entire week of the class. So if you don't completely get what's going on with LEDs yet, don't worry about it. We're going to get there. We're focused on the code half right now. So that's it. Otherwise, these next 2 slides are actually the same because the same pitfalls have been there. What I'd like to do is to stop sharing my screen, hear from all of you. And I think the big thing is going to be to interestingly hear like what have you been up to, 1, and 2, what are the pitfalls that you've run into Arduino that you've solved that you're like proud of, that you think other people might have fallen into and that you think are worth it for us to explain, or any questions that have come up. So with that, anybody have any things that you want to share or talk about?
I can share on the very most basic level, which is where
Sure.
I am in Arduino. This is my absolute first foray into any sort of microprocessor or C++ or any of that. So just silly little things, especially for people who are new. things that Corey has been helping with, little things like smart quotes. When something copies in and it changes the quotes, and they might look a little different, but it changes everything. Bracket types. So sometimes, basically, when I'm copying and pasting, I don't know if this is a Mac thing or what. I need to go back in and double check some of the characters. Also, pretty confidently a Mac thing is that it always needs me to go into Arduino and define the port pretty much every time I hook up the Arduino. So I've just learned to do that, and that's fine now. And then, of course, the turn it off, turn it back on thing, when we were both stuck on something, I forget it was last night. And then trying a bunch of things, and then finally just unplugged and replugged it, and then it worked fine. So it wasn't even a problem with the code. So those are just very basics, but it's starting to make sense. So that's where I'm at.
Cool. Yeah, and that reminds me of a thing that Ruby and I discovered, which is that Max, remember, it was doing the do you want to explain it, or should I do it? Okay. So when you upload a sketch and it starts on the serial monitor, it'll make it I don't know, 15 lines into your code, and then it unpowers and repowers and restarts the Arduino. So you can have a code that's loading totally fine, but on some or maybe all Macs, when you do it, it does some handshaking maneuver with the Arduino so that it cuts power and restarts power. So you get a weird output that's not as clean as what it would look like on Tinkercad, where it's really simulating the Arduino, and it's perfect every time. So
how'd you work around it?
Oh,
it just is, right?
Just is.
It's kind of like, I don't know, a ketchup stain stuck on your shirt. You can get it off. It's just, you just gotta live with it.
Yeah. And I think that's basically it. If you were to run the Arduino off battery, you wouldn't have the problem. It's just while you're in the process of coding it.
It's just something to know, because especially when you're first learning and you're 34 plus 5 is 8 twice, and then it's the right thing. What is happening there? And then when you recognize the pattern and see what it's actually doing, then you at least know what that is, and it's not you, which is nice discovery.
Yeah. And I had some good discussions about how you expect an Arduino to be such a smart device, because now there's Apple Watches that are smaller than an Arduino, and they're super complex things. But Arduinos are still you can't forget that they're a very old piece of tech. So they're not a smart device, and they're going to have dumb things like that happen that you need to just know, okay, this is a weird ketchup stain, and how to deal with that. All right. What are other things that happen that you'd like to share? Maybe you could tell us a little bit more about what you did.
Okay, yeah, I went into one of the instructions on programming AT-Tiny 85 chip. A major pitfall was it had the wrong frequency specified there. So that was kind of annoying. So I would run it again and again and again, and got pretty familiar with the Arduino IDE. Playing with the baud rates, trying a lot of different suggestions from the message boards and stuff like that. So I would recommend looking on the spec sheet of the chip that you're trying to program if you do decide to go this route, because the spec sheet for the chip would specify the frequency that you would need to communicate with it once you get all the plugins in and stuff. So yeah, so I got pretty familiar with the Arduino IDE,
Cool.
but not much with the code.
Can you hold it up? I want to give everybody the 20,000 foot view of what you did.
Okay.
So what Wolgata's got going on there is he's got an Arduino, and then attached through a special connection, SPI bus, he's got the little chip is basically a tiny Arduino brain. And he used the big Arduino as a programmer for the smaller one, so that if he wanted to, he could make a project just based around the little chip. So that if he unplugs all of those and just powers the little guy, it can run completely independently of the Arduino, and he can write the code in the Arduino IDE, upload it to that chip, and it runs totally separately, which maybe sounds like a weird quirk, but if you want to build 10,000 things, you want to buy the cheapest chip you can to make that happen. And so getting just one little chip to run on its own is really helpful. And so that's the first step to making that happen in a broad scale. If you were to try and invent something, you'd want to get down to just a chip instead of having the Arduino and all of its trappings.
Not sure what I'm going to do with the chip yet, but it was fun playing around with. So
yeah, absolutely. Yeah, what he did was he made the raw chip into its own Arduino using another Arduino. He used an Arduino to make an Arduino out of a little chip. And it's definitely a more advanced task. It's totally a fun one to nerd out with, though, if you get there. Jamie, you did some cool stuff. You want to tell us about it?
Yeah. Well, the week I was supposed to take off, I didn't. There were some complications with the van, so I put that on hold, and just actually was really great. I refocused just on the coding. I did want to do the chip, but I decided I just wanted to really get back to the basics of, for loops and while, and even just push button, like toggling, just doing, understanding toggle button logic. You'd think it's simple, but it really isn't. And so I reviewed that, and then you and I spent probably a whole day working on my alarm system. So I'm trying to build a really obnoxious alarm for my van that goes off if multiple things happen either together or independently. So if someone opens a car door and the temperature changes drastically, the alarm will go off. If it senses motion or movement, it goes off. If it senses a change in light, it will go off. Sound, it will go off. So we messed around with how to make that happen, because having them happen independently was a little tricky, but we got that to work. And then what else? Equation of the line, like just kind of, which is actually the map function I found out last night with Corey, which is really cool to know how to do that quickly now. But I learned it the old school linear algebra way, where I get the slope of the line and do the whole equation of the line with the slope. And I can then use a potentiometer to turn to fade an LED on and off, like to control the voltage going through it, but like with a lot of resolution. Is that the right way of saying it? Like, just
yeah.
like
There's I would categorize as what you did over the course of the weeks as you really did a deep dive in starting to think about Arduino projects as just a collection of inputs and outputs, and then like the logic that connects them together. So
Right.
like your light sensor is got its own little circuit, and we sort of isolated that as a thing. And then you pull that information in through an analog input, and now you've got an information stream. Right now you've got access to how bright is it. And then from there you can say, if it's this bright, I want a thing to happen. And if it's not that bright, I don't want it to happen.
Yeah.
Or like you can use big temperature swings to say, if the temperature changes by this much and in this short amount of time, where you've got multiple linkages, where you're keeping track of what's the temperature been over the last 5 minutes. Is it the same? Is it a big swing? Is it a small swing? And you can start to think about, how does the information that you get from sensors impact an output, like just ring a buzzer. And so I think you really were addressing sort of those electronics pieces that go along with the Arduino code that we've got a whole unit of 2 weeks on coming up.
But it helps me also learn it. Like the projects themselves actually make me focus on rewriting the code, which I did a lot of. And then I rewrote it. I'd like watch different ways of doing it and try to think through and do it my way, even though it might not be the best way. I would think about the project, try to do it myself, and then see how other people did it and learn different ways of writing the code or styling it, or writing functions for it. And also just like communicating with the Arduino, like using the serial print, like the parse int and serial read string, like revisiting all of that, just doing coding, not using any circuits, and then actually using them to turn things on and off was also kind of cool. And if anyone, by the way, this is something that's been happening a lot, and I thought this was a glitch, but in the serial monitor, if it keeps repeating something, if you're at the place where you're doing parse ints and you're talking, like the computer's asking a question of the user and you input, and then it'll ask the question not once but twice, which is a weird glitch. I found out that next to the baud rate, you would have to set the serial monitor to no line ending, and that will just have it, the loop, ask that question once.
Gotcha. Yeah, and that's a good
Yeah.
point. Also for baud rate is a thing that, like, we've done a lot of serial print, or serial would begin and then the number 9600. That's actually like how many beats per second the computer's expecting for ones and zeros, right? Like your computer's talking ones and zeros all the time, and that's saying that you want 9,600 ones and or zeros in a second. You can actually make that faster. So it's like 1152, 1,152,000. So you can get more ones and zeros, but the standard is pretty much always just 9,600. And so if you're ever like, if you want to see something weird happen, you do serial begin at 9,600, and then set your serial monitor to a different baud rate. You get a bunch of weird garbage coming out of the Arduino, which is kind of fun.
Yeah, it is. But yeah, there's like other things I didn't realize that you can select within the monitor to adjust it to make it react a certain way. And so there's something in there where it has nothing to do with the baud rate, but it's next to it in the monitor. You'll see it. So you can set that if you're having any troubles. And then I also built, because I also just need to take a break. My brain was exploding. So I built this like circuit. I want to like learn how to find solder. So that's also what I did last night. They call it like an Atari Punk console. So it just makes like really obnoxious noises, but it works. So
yeah, there's
Are you
tons
not
of fun.
gonna demonstrate the obnoxious noises?
Yeah, I want to see obnoxious noises.
Yeah,
bring the noise.
Let me get that battery in there.
Let's see, Aaron, were you up to any Arduino projects this week?
So I went down a very deep rabbit hole, and the short answer is no, but I discovered like a thing that I think is going to work for me really well. And it's called mysensors.org. And they have their own library as well, which I've downloaded. And they have a bunch of pre-baked examples on how to use each sensor. And everything is all within the website. So at least I've looked at a lot of different sites, and I think what I have a hard time doing is I need to like have it all in one place and learn it all like one source's way to be able to sort of like get a sense of what's going on, and then I can sort of pick things off the internet that I might be able to understand. So that's the background. It integrates into a system called Home Assistant that I use a lot of. So I'm really interested in creating my own sensors for automating things in my home. In particular, I really like want to make a motion sensor, a humidity sensor. Actually, really just a humidity sensor would be a good place to start. I don't think I need to like get too crazy. For knowing when to turn on the humidifiers in my apartment, particularly for my plants as well. And I'd really like to like learn how to use a button. I think that's my first like goal, is I want to get a button to do something. And then if I can turn that into a binary sensor, I could be like, cool, I'm going to bed. I can just like push a button and that could shut off everything in my apartment, since it's already connected to my home assistant. So there's not a whole lot of barrier. I just need to like figure out where to start simple, I guess.
Yeah. That's really cool. And I like looked at, I've got it pulled up now. There's tons of interesting things to go with that. We're going to have a unit that's focused on the electronics concept. So like, how do you implement a button, and how do you do LED things, and how do you do all of those pieces that will eventually be the inputs and outputs that we tie to Arduino? Kate was saying earlier in the week that it feels like there's pieces missing to Arduino, that there's parts that are like right across the border of what we're up to. And like when we're just in the code world, you want to cross over into the next universe of electronics pieces, and we're gonna be there, and there's zero shame in like going for it right now. And many people I think learn better that way. We're just doing it this way because it gives us a cohesive experience. But if you wanted to go off the rails, I'm 100% in support of finding interesting projects that you want to do that are sort of in the spirit of the problem of learning these ideas.
Is this what you would use relays for Aaron's thing, since it's household?
Yeah, interesting. You might want to know, like a good output for you would be relays, where you can turn things on and off with Arduino, like level voltage and power, but you can use them as electronically controlled switches to turn house mains voltages on and off. So if you have like a light for your plants that you want to turn on and off, you can wire it up yourself with a relay board. So it's a really cool trick. Ruby, do you want to talk about what you did?
Yes. Hi. So I struggled a bit, mostly because I didn't have enough time. But I figured a solution to that, and I'm gonna have more time for class now, which is really exciting. And I met up with Corey, and I kind of pushed through, and it became a lot easier to understand once I was actually doing it, you know, conceptually. Sorry, my air is really loud. It's a lot easier to understand once I actually had the code out there and was actively like seeing how it was working. So I think that like when I'm gonna because I'm gonna go back and look at the rest of those problems, 5 through 10. If I just think of them as like projects, and like I saw this in the slide, like projects that are containing or organizing information. If I just think of it in a more like physical way, I think that is the most straightforward like way to understand it. Because I can see why it works conceptually, but I don't really, it doesn't really click at all until I see it in a real world like example. You know?
Absolutely. And that's where I think that that's why I bought the pile of LEDs, is so that you can grab a few and like see what happens when you turn it on and when you turn it off, and like do all of the times can go really fast in code. So like you make everything have 100 millisecond delay. It's still just a 1/10 of a second. So like give everything a nice slow delay so you can watch it happen. You can see the serial monitor output what's there. I've spent hours and hours and hours doing exactly that. And it's a noble quest that you're on, Ruby.
Thanks, noble. I like that. Like there's different ways to do things, right? And that's what we're looking at now.
Yeah.
All looks the same to me until you pull out something like controlling the humidity in your apartment or changing LEDs and the way that they fade. That's where I'm at. But it so far so good. This is cool. I'm rocking over here. Yeah.
I want to appreciate what you just said, Ruby, because like I too need it to be like grounded in something physical and real. And that gets me into trouble sometimes because I want to like, in order for it to be grounded, that's going to be more complicated. And I don't necessarily know how to like parse it out. So, and that it takes me a while to figure that out. So I appreciate that I'm not the only person that's like that.
I really like, everything I've learned about Arduino has been through projects that are grounded. And so I feel like that's completely the way that you ask the questions that get you started. And then when you really drill down and like, how does this work? How did I get this weird sensor to do a thing? Like that's the moment where you do the learning. It's like once you've got an idea and a concept, and either you need to make it happen or you want to understand what you just did because you followed somebody else's tutorial. I think those are the critical moments where you can learn the most, where like you find something that's getting you to ask the questions that you really want to have answers to. So it's a super, Arduino is like a really nerdy and empowering question asker. And you just need to like really dive in as fully as you want to. And that can be at various different levels. But the more you learn about it, the more empowering it becomes. So it's a really cool thing to like get started, play around with these code ideas, and then quickly hop into projects and then let those expand your skill set instead of just like, if you wanted to be developers, there's a different program you could do. We want to do projects, right? Like let the projects guide you in the learning and how you're building stuff. So that's awesome. Ada, your screen is off. Do you want to, I know that you had a rough computer week, but you have anything to say, to add in?
Yeah. I mean, so my laptop screen just stopped working entirely. So it was at the Apple store for the last week, and I'm getting it back tomorrow. So yeah, which is exciting, but unfortunately it was not before this class. Mm-hmm. So I didn't really get to do any Arduino work. But so I was focusing on other stuff. I did a little bit more modeling of like some additional pieces of the nightstand I'm trying to build. I did a lot of cleanup work on the CNC cut that I did. And there was something else that I was going to say.
You did the metal lathe class, right?
Oh, yeah. I took the metal lathe class, which was great. It was really, really good. But so yeah, I don't have, an update or anything like that.
Lior was super impressed with your progress on the CNC cut. He was really amazed at how good the cut looked and how neat it was all put together. I'm excited for us to all hop into the CNC week when we get there. There'll be a CNC unit that's coming, and then there'll be a Make Something Big week that I was nervous if the Gerber would be up and running, but I think it will be. I've almost got the dust shoe done, and that's like its own whole thing, but we'll make big stuff, real big stuff. And so we'll hopefully be able to say like everybody gets a sheet of plywood and then just sort of go. But I've been working on 3D modeling and making that dust shoe that we'll all be able to use. So it'll be fun. We'll be able to use that and put a mark on it, which raises a good question. Maybe I should share my screen again just to go through this last thing. If anybody feels like taking it on, there's a
Corey, can we hear Jamie's alarm?
Oh yeah, I want to hear that alarm too, for sure.
Okay. Yeah, it went off before. Sorry, Aaron, it went off when you were talking. You hear it?
Yeah.
I think actually the battery's dying on this one. I'm not sure if anyone can hear it. It's actually much louder. Sorry, it's a little anticlimactic. I need to put in another battery, but someone else can talk while I do that.
Oh my god, wait. Sorry.
If anyone like the most solid creation we've had this week too, so it's kind of cool.
Oh, here we go. Where's that? I don't have it in a box, so it's a little hard to maneuver right now. There's like multiple buttons on it. Here we go.
Yeah, it sounds the castanets.
Okay.
Is that the?
Exactly what I just said. Yeah.
That first sound was like a horse-sized cricket, like an angry one.
Sound like a maraca.
Mm-hmm. Let's see. All right, so the
that's all I can take. It might give me a seizure, actually.
yeah,
Yeah. That might be a holiday gift. I'm trying to actually I'm doing this fundraiser for MakeHaven on Facebook, which I don't go on much anymore, but yeah, I'm trying to sell it. Not only to just get it out of my life because I got my practice out of soldering, but maybe make a something. I don't know.
Yeah.
And if I don't sell it, I'll put it in someone's stocking as a gag gift. So
That sounds fun. Yeah, it sounds like tons of cool things have happened. There's lots of neat experiences to have with Arduino and building things and projects, and I really look forward to more of them happening, including annoying alarms and like little glowy things and blinky ridiculous buttons that are all over the place. Those are the sorts of things that make for great Arduino projects. And so hopefully we'll have a lot of little clickety clacky castanet sounding things and weird alarms that we make over the next couple of weeks. But this is what I've been working on, and I think this is shared with you all. I was wondering if anybody wanted to try. I'm laser cutting these out of acrylic. This is going to be the dust shoe. It'll suck dust and chips up out of here while the spindle is down here cutting. And so what I was hoping is that we could get a little character of the MakeHaven guy peeking out around this corner so that he's laser etched into that acrylic. But my art skills are terrible. But my hope was that it would be something like, here's some characters looking around a corner, that it would be the little MakeHaven guy like looking around the corner of the dust shoe, right? That you'd have something like that is instead this little MakeHaven robot that's peeking around the corner. It would feel very on brand. It's completely not necessary, but for some of you, I'm sure you could just like whip it up in a minute or two. When it's not my area of expertise. So I just wanted to offer that. If you think you can do it, there's like a little, I can give you an SVG. So if you're good at vector art, it wouldn't be this SVG, but I can give you an SVG where you draw the robot into that shape. So like a little person poking their head around the corner with waving at us or something.
do you have a vector of the original robot that one could just manipulate the points?
All of those are on the MakeHaven website under member resources. If you go to that page and search for logo, there's a Google folder that has the MakeHaven logo and the different robot logos as JPEGs and PNGs and SVGs. So you can download whichever ones are helpful there. And if you can't find them, I can help you find them.
Yeah, it's a cool thing. And also I put up this video just to see sort of how designs happen. And so this is a fun one that's just like Fusion 360 will let you fast forward through a design that you've made. So like this is maybe helpful for in the future when we get to 3D modeling, for seeing sort of how you can think about a 3D model and like make different shapes as you go. So this is after years of thinking about it. There's patterns and forms to this. I actually do a lot of sheet metal bending in this. I pretend like the plastic is sheet metal, which is a more advanced modeling move, but it's really helpful for getting the weird bent shapes that I'm using in the dust shoe. So there's lots of interest. These are like previews of where we're going. You're gonna learn how to do all of this business. And so if Arduino is if it feels like a slog at moments, you're gonna get these nice visual experiences later too. And so we'll eventually be done with electronics. The next unit, and that brings me to the last thing that we should say, is that this is Arduino week. We're going to take next week off as like, I guess we're observing Hanukkah as a class. So happy Hanukkah, everybody. And then we're going to be back at it for 2 weeks on the laser and vinyl cutter so that we can work on those skills. And if you feel like you want to get ahead, because that will be a lot of people trying to filter through 2 machines at once, if you wanted to hop onto the laser cutter or the vinyl cutter early and get a badge for that ahead of time, that could be a good move, just so that you have that experience. You've got the badge out ahead and you can be focused on just like the project when it comes instead of the project and the badge. And several of you, I think, already know how to use those machines. So it might be like an area of strength that you're working from. So that's cool too. But it'll be a definite shift to go from like the all conceptual cerebral code business to the very visual of the laser and the vinyl cutter. So that's where we're headed. There's lots of exciting things coming up in the near future, and I hope that you're as excited about them as I am. I just want to see what sort of weird stuff we keep making.